All right, welcome everyone to our second stream for our algebra topic level 2. Now, in our previous one, we covered a lot of basics, fundamentals from factorizing and expanding, solving equations, the exponent laws, and more. And we're going to complete all of the rules and fundamentals that we need for the level 2 exam today. And some of the topics are going to include solving equations, solving quadratic equations and the differences in how to solve them, the discriminant and the quadratic formula, as well as solving equations with expressions in the exponent, so where x is in the power. We have some merit and excellence questions, I believe, at the end. And we also are going to cover quadratic equations from a graph if we have enough time. That's kind of like a little bonus one. We're going to see how long we do today. We haven't had enough people for me to justify to have a 2-hour live stream every week for each of the levels. So I need you guys to share the live with your friends. You guys can do that now. Go on your phones, share your live with your friends so we can have more viewers active. Otherwise, we will not be able to continue to have long 2-hour streams. It's just too much preparation from my hand if not many people are interested in watching yet. When it gets closer to the exam time, of course, we'll reverse that. Okay, now, again, if you guys have any questions, pop them into the chat. Let me know what you guys are looking for. Now, here is our first question. Very, very easy. But the reason why we're doing this is because we want to see the differences between solving linear equations and solving quadratic equations. Now, when we are solving, oh, that is a very big pen. 1 second. If we're solving, that means we want to have x equals and then some number or expression. So of course, now here we see our x over here. And if we want to have the x by itself, there's two things that are in the way, the 3 and the 7. And generally, when we want to solve linear equations so that there's no squared term, there's no x squared, then the first step is usually to isolate the x terms. Yeah, so we want everything with x on one side and everything else on the other side. So if we do the step over here, the 7 needs to go. It doesn't have an x. So what do? The opposite of 7, and this is again a very big pen, excuse me. Minus 7, but we have to do it on both sides. So if we do that, we're going to end up with 3x is equal to 12. I assume so far everyone is very happy with this, and that's why we're going straight to step 2, which is to get x equals by itself. Now in this case we have a 3 in the way that still needs to go, and we are dividing both sides by 3 because it's 3 times x. So we're going to divide both sides by 3 to get x is equal to 4. Now, this is part of the year 9 and the year 10 and the 11 curriculum, so I assume that everyone is very happy with these steps. Just keep in mind that these steps to solve for x are different for when we seek a quadratic. And we'll see that as soon as we have a quadratic term, these steps no longer work. Okay, one quick example again. So here we see it's again linear because we have y's, we have no squared terms, and we're going to do the first thing, which is isolate the y's. So here we have 2y, here we have 5, we're going to put them together. Here we have 2y, the opposite is minus 2y, so we're going to do that on both sides. 5y minus 2y will give us 3y. Then we still have the minus 8, and on the other side we just have a 10 or positive 10. Now, remember the first step is to isolate y, just y on its own. Everything else on the other side, that's how we solve linear equations. So we need to get rid of the 8 here. It's minus 8, so obviously the opposite is positive 8. So we're going to do positive 8 on both sides. And then we're going to get to 3y is equal to 18. And again, once we're here, you guys know what to do. It's just y by itself. So we're going to divide both sides by 3. And then we're going to get y is equal to 6. Okay, wonderful. Now, I just want you guys to see the difference between solving when we have an x and solving when we have an x squared. A lot of students usually try to isolate the x here, which has these two terms, and then they have the 6 on the other side, and then they kind of get stuck. So as soon as you guys see that there is anything with a squared term, the mechanics, the steps to solving change. So the first step here, is always to make it equal 0. So we're going to make it equal to 0 on one side. This is already given here, right? We already have equal to 0, so everything is on the other side. Yeah. So instead of the other one where we isolate x and put everything else on the other side, here we want everything by itself on one side and 0 on the other side. And then the second step is to factorize. So if we're now factorizing the left-hand side over here, we have done a lot of factorizing in our live stream last week. So we see it's a quadratic, it's a standard quadratic with no number in front of the x squared. So we're just going to go straight into brackets. And how do we figure out what the brackets are? Well, that was by writing down the factors of 6. So that is 1 times 6 and 2 times 3. Now, when we have these factors, which ones add now together to get 5? That would be positive 2 and positive 3. So we're going to get with x plus 2 and x plus 3. So as soon as you guys see a quadratic, it is a different method to solve. Step 1 is make it equal 0. Don't forget this, otherwise the factorizing doesn't work. Or at least at the end we couldn't write what x is. The second part is factorize it. And then step 3, set each bracket to 0. Hey, how are you doing? X squared plus 3x plus... yes. Okay. So when you're looking at the question that you've got here, yeah, you're separating the middle term, right, into x plus 3 and x plus 2, which is kind of like the step in between, plus 2x plus 3x plus 6, right? So, and equals 0. I assume that it is a typo that you mean equals 0. That is basically the step beforehand. I would expect that everyone who has done the quadratics before, especially from our last live stream, can go immediately from here to the factorized form. But you're absolutely correct. Yeah, that's correct. Awesome. Okay. Now, once we have these, we have 2 brackets here. One is here and one is here, and we're going to set each of them equal to 0. Why do we do that? Well, because in the end, we have 2 brackets, which is 2 numbers. Let's call them a and b. And if we multiply them together, we get 0. So the reason why we factorize here and why this is our method of solving is because this is the only way for us to know what these kind of numbers are. If we have 2 numbers a times b and they give 3, there's infinite many options. Yeah, there's 1 times 3, there's 1 over 10 times 30, and so on. There's lots of different ways to get this. Now, the only way that we can actually see what a and b are is by having it equal to 0, which is why we have our first step. And now the reason why we know something more than before is because when we multiply 2 numbers together, then we get 0. That means either this is equal to 0 or this number here is equal to 0, because that's the only way to multiply 2 numbers together and get 0 as the result, if one of the factors is 0 itself. So let's take this out, and we're going to start with our first bracket, which is the left one here. and we're going to set this equal to 0. So we're going to get x plus 2 is equal to 0. And we can solve this just like a linear equation. We had just have an x, so we go minus 2 on both sides. So we get x is negative 2. Oh, what happened? Everything's still good? Yeah, just locked myself out. Morning, how are you guys? Okay, now we have, why is it morning, hey? Okay, why do we have x is negative 2? Yeah, that's our first one. The second one here comes from this bracket, x plus 3. And if we're solving that one, let's get rid of this one so we have more space. Then we get x is minus 3. So now these are the two options. And again, in mathematics, we have either one or the other one is true. Now in mathematics, or means either one or the other or both. So it could be this and this at the same time. Yeah, I do remember you, Abbas. Absolutely. Level 3 help is on Mondays, 6 to 8 p.m. Every week. And also I've got a complex number course already completely on YouTube. I think it's like a 10 video course. These questions are made up at the moment. We'll do question papers from the Algebra Level 2 paper a little bit further down. We're just going through all the fundamentals. And once we have finished all the fundamentals, you guys can solve any question on all of the papers. Yeah, Williams. Okay, cool. So when we solve this, what did we actually do? And this is the concept part that a lot of people struggle with. What did we actually do here? We found x here, but what does that actually mean? Let's have a quick question. Let's have a quick look at a picture on how we can do this one here. So if we have a quadratic like this, sorry, it's not very nice. Oh my God, that's a terrible drawing. There you go. When we are now solving this equals 0, yeah, so we have our quadratic, which was this part over here, and we set it equal to 0, you can think of this as y. That's the y. So that means we are looking at y0, which is here. So we're looking at points where y is 0 and we have our equation at the same time. So when we say we solve for x, that actually means we are finding the x-intercepts. And most of the time we call them roots. Yeah, so you guys are required to know what roots means. Thank you very much. Okay, which question did you have? You had x to the power of 3 plus y to the power of 3 plus z to the power of 3 is k. So that question is actually part of the level 3 part because it's in 3 dimensions. We're probably not going to get into solving one of those today. Okay, wonderful. Now again, if we have this question here, if you guys already watched my stream last week, then you guys know this is again solving a quadratic. What do we do first? First thing is we check if there's a number in front of the x squared, which it is. So what does that mean? Now we have to solve according to a different method. So here we have a 2 in front. Remember, after that we check, can we divide each number by 2, the leading coefficient? And the answer here is no. So if we can't divide any of those, then we need to go to our third part of our factorizing methods. So that was 2 is multiplied by -5. That gives us -10. So let's just ignore the negative and write down all the factors for 10. It's basically the same thing as the factorizing method if we don't have a square term. If we don't have... I was just reading the chat. Sorry, guys, I lost my chain of thoughts. All right, let's have a look here. Which of these do we take in order to get to -3? Well, 2 and 5 can make a -3. There's a difference of 3 between 5 and 2. So we're going to get -5 and +2. Together, if we multiply them, we get -10. And if we add them, we get -3. So again, how do we do this? Just like before, we write down our equations, we write down our x's and the numbers that we found. There we go. But we're not finished here. Have a think real quick. What do you guys need to do here? What did we forget? This is just a normal factorizing method. There's one more step. Okay, let's have a look. So here we have a number in front of the x squared term. So that meant that each of these still need to be divided by 2 and then simplified. So if we simplify each of the terms, then we're going to get x minus 5 over 2, and we're going to get x plus 1. And now, if we were left with a fraction, what did that mean? That meant that that number moves in front of the x, and we're done with our factorizing. So we ended up with a 2x minus 5, all multiplied by x plus 1 is 0. Now the steps were still the same, right? So what was the first step? So we had step 1 is make it equal 0. Yeah, we've done that in the beginning. That was given to us. What was step 2? The second step is factorize. And then step 3, each bracket equals 0. Yeah, I don't want to write it again. There we go. Okay, so now we have each of our brackets. Let's start with this first bracket over here. 2x minus 5 equals 0. It's a linear equation. Now there's no squared term, so that means all the x's on one side, everything else on the other side. So we're going to get 2x is equal to 5. And then divide both by 2 is 5 over 2. And we're not surprised that that is actually this number over here. Now the other side over here, we have x plus 1. Sorry, x plus 1, and we know that's 0. So we're going to solve this again, minus 1 on both sides. So we're going to get x is -1. Yeah, so if we multiply 2 and 5 together, so these two numbers here, then we get 10, which is the multiplication part. And if we add them together, we should be getting -3. So we need to decide on what we have in front of these. We can have a +5 or a -5, or a +2 and a -2. And it depends which one. Yeah, we can combine them in any way. So in this way, we're going to combine the -5 with the +2 to make a -3. All right, just a last quick reminder before we move on to the next topic. So what kind of factorizing method is this one here? Well, we see no middle term, so that means this was a difference in squares. So we write our two boxes, both of them squared, and difference means minus. So what goes in the first box to make an x squared? That has to be an x itself. And what goes in the second box to make the 16, which is this part here? So what squared is 16? That would be 4. There we go, and I'll color this one here as well. And of course we know the minus in the middle and the minus here is the same. So what does that mean for our factorizing? That means those are the two components, x and 4 and x and 4 again. And if you remember, one is positive, one is negative. Cool. And then from this part here, we get x is -4. And from this part here is we get x is +4. So these are our two solutions. Yeah, correct. That's the difference in squares formula. And if you write it out, a minus b times a plus b, the middle terms here go away, which leaves us with the first one squared minus the second one squared. Okay, so what I want you guys to take away from here is that everything that we learned last week for the factorizing is mostly used when we're solving equations, especially when we solve quadratic equations. Now, let's have a look at a different concept in year 12 that we haven't talked about yet. And here at the top, I've put this from the formula sheet, and this is the equations and the formula for the quadratic equations. And it tells us here that if we have ax squared plus bx plus c equals 0, so this is giving us the condition that we have equals 0, which is what we need for solving. Yeah. So if you guys ever use the quadratic equation, make sure you guys have it in the form something x squared plus something x plus a number is equal to 0. And if you guys do, then you guys don't have to do the factorizing part. Then you guys can simply use this equation here to find all of the solutions for x here. Remember, what are the solutions when we find it? That is the roots, the x-intercepts of this question. Now, how do we do this? Well, this is ax squared plus bx plus c equals 0. And we're going to match. The a here matches with the number in front of the x squared, which gives us a is equal to 1. Then we have the number b is the number in front of x. So we're going to get b is negative 5. And then we get the number by itself. We get c is 6. So once we have those found, we can just substitute these values into the quadratic formula, and they give us all of the answers. So it's quite a complicated formula if you guys have used it for the first time. So let's have a look. Both x1 and 2 values, I don't like how it just says x, but it's okay. Both x1 and x2 are given by negative b plus minus the square root of b squared minus 4ac divided by 2a. Okay, so what do? We have our values for a, b, and c. We're just going to substitute them into this equation. So we're going to get x1 or 2 is given by negative, and now we have to be careful because if we substitute in b is negative 5. Maybe I'll do it in yellow here. B is negative 5. Once we've substituted that in, we get plus minus the square root. And again, we need to substitute in b. And remember, every time you substitute, I highly recommend putting in brackets. Because when you replace this b by this, then this whole thing needs to be calculated first. So we're going to get minus 5 squared minus 4 times, well, what is a? A was 1, that was green. And then we're going to get multiplied by c, which was 6. And then we can put our square root over the top. There we go. And now we're going to divide by 2a. So 2 times, and a was 1. Now, you can put this in the calculator just like this. Yeah. And then you get your values x1 or 2. Let's have a look how we actually do this. Now, we have negative 5 squared, and I'm looking in the square root part here at the moment. Negative 5 squared is a positive 25. Minus 24 is 1. So that's the square root of 1. The square root of 1 is 1. So we're going to get a plus minus 1. Well, negative 5, 2 negatives next to each other make a positive. So we're going to get positive 5. And then at the bottom, we get 2 because we have 2 times 1. So if we solve this now, all we got to do is separate these with the positive and the negative here. So we get one option, which is the first option is going to be 5 plus 1 over 2, which is 3. Sorry about that. There we go. And the second option for x2 is going to be 5 minus 1 over 2, which gives us 4. There we go. So now we have those two options, and we could have done this with factorizing, I guess, as well. Yeah, but these are our options to solve here. So what we've just done is basically solved in a different way. We didn't need to use the step-by-step method that we've given because we have a formula. You guys are welcome to use this at any time, but there's another trick that I want to show you guys, and that is how to use your graphics calculator. So let's get that out. Let's get our graphics calculator out. And the way that we solve this in the graphics calculator, and you're allowed to do this as soon as you get to this part where you write equals 0. You're allowed to fully take your graphics calculator as advantage and solve the question. So what we need to do is we need to go into the menu, and we're going to go for equation, which is at the bottom here. And now we need to select what type of equation we have. Now we have a quadratic equation, which is a polynomial. That's what we discussed last time. So we need to press F2 over here for polynomials. Don't use the solver. Don't ever use the solver. Okay. And now what degree do we have? Well, the degree is the highest power. So the highest power here is the squared term. Yeah, so we have a 2. So we're going to press 2. Once we have this, you can see at the top that we have a ax squared plus bx plus c equals 0, just like in our formula sheet before. So what is the value for a? The value for a is 1. The value for b is -6. Always remember to take the negative signs in front of numbers. That is one of the most common mistakes that students do, which is not taking the signs in front. And once we press enter, we get ourselves the answer. So here we're going to get x is equal to 3, or x is again 3. So this one here has x equals 3 twice. Now, this is how we use the quadratic formula, but what we actually want to do for these questions is find the discriminant. So let's have a quick chat about what the discriminant is. And the way that we deal with the discriminant is by just simply looking at a graph. That's the easiest way to look at it. We know that our quadratic can look in 3 different ways, and hopefully I can somewhat draw them nicely, somewhat symmetric. Don't worry too much about my drawing. There we go. And then we're going to have one over here. Okay, now we have 3 quadratics here. We have the red quadratic, which is F. We have the green quadratic, let's call it G, and the blue one is going to be H. So what does the discriminant have to do with a quadratic? Well, the discriminant tells us the following. So it tells us how many intersections there we go. And for we have, yeah. So here we mean the x-intercepts, yeah. And I'm gonna just write roots because most of the time we call them roots. So let's have a look at the 3 options that we have here. One option is going to be, and that is the blue one. We have no roots, yeah. We do not actually go across the x-axis. We don't have intercepts, and we're not doing anything with it. So what are the other options? The other options are that we can have 1 root. Yeah, so that's our green one here. So we have 1 root. And the third option is that we have 2 roots. So we have 2 ways to cross the x-axis. Yeah. So let's have a look. How can we actually use the discriminant now to tell which one we have? Again, we have either no root, that means we're not crossing the x-axis, or we have 1 root, which means that we're crossing it at exactly 1 point, and that usually means that the vertex is on the x-axis itself. And the last part is that we have 2 roots, which means we have 2 distinct numbers, different numbers, unique numbers for our roots. Okay, so how do we actually find these? How do we actually use the discriminant, and what is the discriminant? So again, let's have a look at your formula sheet over here. And I'll kind of put this here in the corner so we can continue writing with it. So we have been given our formula for the quadratic equation. And when we look at it, there's a very large square root. Now, whenever we have square roots, then we kind of have some issues because square roots are very dangerous. They cannot have negative numbers underneath them, right? At least unless we go into complex numbers, which is level 3 content. So whatever we have underneath that big square root, this number here, over here, has to be either 0 or it has to be more than 0, so a positive number, or it can be a negative number. In all three situations, something else happens. Something completely different happens for each situation. So let's have a look if we have the square root of a positive number, let's say 9. If we have the square root of 9, well, there's actually 2 ways to get to 9, which is positive 3 and negative 3. Now here's the thing. When we write the square root of 9, that actually gives us only the positive option. This part here where we have a plus or minus 3, this is only when we have something like x squared is equal to 9. So here we would take the square root on both sides. We have x is the square root of 9. Here we need a positive and a negative. But by itself, that square root, yeah, so the square root part, this number here has to be a positive number for you guys. Yeah, otherwise there's no solution for this equation. We cannot solve this square root. So when we now have a look at our formula sheet, it actually tells you a formula here at the bottom for the discriminant. And you guys need to remember that the triangle is the discriminant. So when they ask any questions about a discriminant, or they ask you how many roots there are, or they tell you there's 1 root or 2 roots or no root, all of that means you guys have to use the discriminant, which means you guys have to use the formula b squared minus 4ac. And if you see, this is exactly the part that is underneath the square root. So that is the one that can either give us multiple answers when x is distinct, or it can give us no answers if we have a negative number underneath the square root. So when we now use this to formulate our rule, there's 3 options, and we've written them down already. There we go. So, and we have b squared minus 4ac. So this is the discriminant. If this is a positive number, so this whole expression is greater than 0, so a positive number, then we can take the square root, which ultimately gives us a positive and a negative of that version. So we get 2 numbers, plus 3 and negative 3, for example. These are then the numbers that, when we put it into this equation, make 2 different x-intercepts. Now, the second option that we're going to get is if we have the discriminant is equal to 0. So what would that make? Maybe I'll write here, this is 2 distinct roots. So let's have a look over here. If we have the discriminant equal to 0, what would that mean? That would mean that the number underneath the square root here, the yellow part, is equal to 0. Well, the square root of 0 is 0. So what we have then is we have a positive and a negative 0. It doesn't really matter because 0 is the only number where positive and negative is the same. So that's why we don't get 2 distinct answers. We just get the 1 because the one with a 0 in it is duplicated. So here we get, we still get 2 roots, yeah, but we get 2 of the same roots. Yeah, so here we have x is 3 and x is 3, like we saw in the last example on the calculator, right? I can quickly blend that in again. Yeah, so you guys can see here we had x is equal to 3 times 2. That means we have a repeated root. We have x is equal to 3 twice. And this is because the discriminant for that question is 0. Okay, the last part for the discriminant is if the discriminant is negative, well, that means a number less than 0. Well, let's think about it again. If we have the square root of a negative number, let's say negative b, negative 9, negative 6, it doesn't matter. Well, think about it. How can that have a solution? Which two numbers are the same that give us a negative number when we multiply together? If we choose a negative number for a, so negative 1 times negative 1, for example, we still get a positive as the answer because two negatives together make a positive. And if we choose a positive, then we still get a positive afterwards. So multiplying two of the same numbers together cannot be negative 9. Okay, so let's have a look. Of course, all of this is in the real numbers. Yeah. So let's fill in the last part to our discriminant rule page. So we have that if the discriminant is negative, we have no roots in the real numbers. Yeah, so we have no answers. And it's very important that you guys are able to go from discriminant to the condition to what it means what it means on a graph. Yeah, so let's have a look. I'll just post this next to it so you guys can take a screenshot if you guys want. Yeah, so if we have two distinct roots, that means our quadratic meets it exactly at 2 points that are different to each other. 1, 2. If we have a repeated root, so we have the same one, that means our quadratic is on the x-axis. There we go. Has the vertex on the x-axis. There we go. Drawing is difficult. And the last part, if we have no real root, this could be either like this or like this, a quadratic that doesn't intersect with the x-axis at all. We're going to get to a couple of questions where we have to use this knowledge from this part, go to this, and then go to what that means mathematically and algebraically. So we had this question here before. It's asking us to find the discriminant. We kind of use the quadratic equation to solve it, to find x, but it's asking for the discriminant. So let's quickly add that in. The discriminant is b squared minus 4ac. And we substitute in our numbers. B was negative 5. Yeah. So we had the negative 5 all squared minus 4 times 1 times 6, which is what we calculated before already. And that gave us, what was it? Was it 1, right? Yes, 1. So what do we see here? We see that the discriminant has a positive number. So what does that mean? We get two distinct roots. Well, one of them was 3 and one of them was 4. That sounds good. Okay, next question. Yeah, we're just going to apply what the question actually wanted. It wanted us to find the discriminant. So every time we have the discriminant, we use the formula b squared minus 4ac. And if we now use this and substitute in our numbers, well, let's have a look. A was in front of x squared. B is the number in front of x, so that was negative 6. And c was the number, which was 9. So we're going to get to 9 squared minus 4 times a was 1 and c is 9. So what do we get? We get 81. We better use a calculator. Otherwise, I'm going to make some silly mistakes, of course, as always. Okay, there we go. We're going to go to menu 1. Okay, so we're going to get 81 minus 4 times 9. There we go, which is 45. Brilliant. Okay, so what does that mean? Now, we don't actually care really what that number is. What we care if it's positive or negative. So again, here we have a positive number. That means we have 2 roots. So if we were to put this in the calculator, we find ourselves 2 roots. Okay, did I make a mistake here? Yes, I did. Of course. B was -6. I was wondering where the -6 went. My bad. Sorry, guys. So we have a -6 squared, which is 36. Minus 36 is equal to 0. That makes a lot more sense because we expected only one root. And the answer here from the calculator was x is 3 twice. So we have x is 3 and the second x is also 3. Cool. That makes sense. And the last question, if we wanted to find the discriminant here, well, again, it's b squared minus 4ac. And we put in our values. B is the number in front of the x. So we get 4 squared minus 4 times the number a, which is 1. And the number c is 5. Let's put this over here. So we have 16 minus 20. And we don't even care what number that is. It is -4, but we know it is negative. So what does that mean for the solution? It means that if we were to try and solve this, we would have no roots, no solutions. And let's have a look what happened if you guys were to try to put this into the calculator. Let's have a look what the calculator would do. See if the calculator can tell us that it doesn't work. We're going to go again to polynomial of degree 2. And a was 1, b is 4, and c is +5. And if we now press enter here, it is actually telling us no real roots. Now, some of you might have their calculator set up to allow complex numbers. Yeah. So for some of you, this will actually not show an error message, but the numbers that are displayed on the calculator have some weird I in it. Yeah. It's on the calculator somewhere here at the bottom. Yeah. So if it has this weird looking I in it, then that means, there we go, this one. Is it going to work? Yeah, something like this. Then the answer is no, not allowed. Yeah, this is not a real number anymore as soon as it has this I in it. Both of the situations you guys can use to identify that there are no real roots in the question. Okay, let's have a look at some of these. Now, we're not going to solve this one with a quadratic equation. We've kind of done that already. But let's have a look at some of these exam-style questions so we can actually use this. And now the way that they do this in the exam is by using a lot of algebra and new variables like k or p, because they don't want you to just put this into the calculator. So let's have a look here. We have a function of x, which is 2x squared plus 8x plus p. And it says to us that does not cross the x-axis. When it says it does not cross the x-axis, what does that mean? This part here is the concept part of the question. And this is the part that most students will forget because they're like, oh, it doesn't cross the x-axis. Okay, cool. But this is a concept that you guys should know. And that means that our discriminant here is what? Well, we have no roots. We don't cross the x-axis. That means our discriminant has to be positive. Yeah. So that, negative. What did it say? I forgot. So if we have a negative, no real roots, then this discriminant is negative. Yeah. Okay. Let's have a look. So it does not cross the x-axis. So that means our discriminant, which is this triangular symbol, is less than 0. It's a negative number. So this is the part that the blue tells us. And this helps us solve the question because now we just have to find what the discriminant actually is. So the discriminant is b squared minus 4ac. And if we have a look here, a is the number in front of the x squared, b is the number in front of the x, and c is the number by itself, which is p. Now, if we substitute all of those in, we're going to get 8 squared minus 4 times 2 times p. And what do we get? We get 64 minus 8p. Now, this question here tells us that the discriminant itself is negative. So now we get a different equation, which means this part here, which is the discriminant, right? We know that this number here, whatever it is in terms of p, is a negative number. And if we say that this is less than 0, that means we can solve an equation now that has an inequality sign. Now, these are solved almost the same way as a normal equation with an equal sign, with just one extra rule, that if we divide or times by a negative number, then we switch the sign. Yeah, so for example, this sign becomes this, and this sign becomes this. It's always the other way around. Sorry, there we go. It's always the other way around. So that is going to be our concept rule when we solve inequalities. So let's have a look here. What are we going to do? We're going to do plus 8p on both sides, right? We want to isolate p. Yeah, we said that if we have only p, no quadratic, then the steps are isolating it on one side and then dividing by what we have, which is 8. So we're going to get p is less than 8. P is greater than 8. And this is the answer of the question. Find the range of values of p. Yeah, so p is greater than 8. Yeah, you can also write it as p is greater than 8. It doesn't matter which way around. Yeah. Okay, this will definitely be a merit question. And if you guys recognize that it is the discriminant and you get to here, this is an achieved, and solving it will give you a merit. Okay, here we have, I think this is a merit or excellence question. Let's have a look what else we got. So we can kind of see. Yeah, I guess we can have a look if we have enough time for that one in a moment. Maybe if you guys want to see that question, put it in the chat. Yeah. Otherwise, there's 2 more things that I want to definitely cover. And one of them is solving equations, because that's what we've been doing for our stream today. But when the x is in the exponent. And last time, what we kind of did is we said, if we have, let's say, 2000 times 1.4 to the power of x is 14,000 or 40,000. Doesn't matter. Here we had an exponent of just x in the top. And in these questions, what did you guys have to do? We have to isolate the term with the base and the power. Yeah, so we divide both sides by 2000. So we're going to get 1.4 to the power of x is equal to 20. And now, what was the trick here? The way that you guys were solving this is by applying log to both sides. So if we move this over here, yeah, what we did is we applied log to this side and log to this side. Why did we do this? Because in the last question that we did last week, we realized that for logs, the powers are multiplied in the front, which is something that we love to deal with if we have x in the in the power. I keep saying numerator. So we're going to get x multiplied by log of 1.4 is log of 20. All right, here's a question for you guys. If I say just log, what base is the log? I didn't specify it, but what base do I have here? What base can I have here? Okay, next part, we needed to divide by log 1.4, which is going to be log of 20 divided by log of 1.4. And that is something we could do in the calculator. So let's grab that out. We're going to get a fraction, and then we have log 20. And in the bottom of the fraction, we're going to get log 1.4. And the answer is 8.9. We're just going to round it to literally one decimal place. We're not too worried about this part being super accurate, just for practice. Yeah. And now we solve this for x. But even though, if we have a look at the calculator, even though we could do this very easily, it still doesn't tell us what log had as a base. So remember from last week, that if we write log by itself, that just means that we have log base 10. Yeah, this is log base 10. You could have used any base, so you could have even done natural log, ln on both sides. It works the same way. Okay, now, while this is something that we learned last time, this question is a little bit different here, and it's still part of the solving equation parts because we're asked to find x. Now here it's going to be very difficult to apply this. While we can still do that, it is going to be much longer. When you guys see a question where there's multiple powers, especially with an x in it, there's a little trick that you guys need to use, which is making sure that the bases are the same. So for example, at the top here, I see a base of 5. At the bottom, I see a base of 25. And here I see a base of 125. And I see that all of those numbers, 5 to the 1 is going to be 5. 5 squared is going to be 25. And 5 to the power of 3 is 125. And how do I know that? Well, I know that here's a base 5. So I should check if the others have a base 5 too. And you can put these numbers in the calculator to double check. You guys don't need to know them by heart. Once we have these match, then we know that we can rewrite this equation a little bit. So at the top, we're going to get 5 to the power of 7x plus 6, because 5 to the 1 is very boring. But then at the bottom, we're going to replace 25 with 5 squared, all to the power of negative x. And then on the other side, we're going to replace 125 with 5 to the power of 3. And again, why do I put brackets? Because I'm replacing one part. This whole number here has to match first. So every time we replace or substitute, then we need to put brackets to be safe. We can always remove them if they're not required. So for example, in the top here, 5 to the power of 1 is not really required there. Okay, so what is the next step here? Well, we're going to use the laws for the indices that we had last time. If we have a power to a power, we multiply them. So we're going to get 5 to the power of 7x plus 6. And in the denominator, we're going to get 5 to the power of, and now 2 is multiplied with the everything in the power. So 2 times negative x, which is going to be negative 2x. And on the other side, we're going to multiply the power with the next power, which is going to be 3p. Okay, why does this matter? The reason why is because now all of these have the same base. And that was a requirement for us to use the base laws that we covered last time. So if we now look at this question over here, here we're dividing terms that have the same base. So if we're dividing, remember that was minusing the power. So we're just going to take this top power and we're going to minus the bottom power. And again, these are big parts that are going together, so we put brackets around them. So we're going to get ourselves 5 to the power of 7x plus 6. We're going to minus negative 2x. And on the other side, the question doesn't really change. So what do I have here? Do I need the brackets? Well, for the first one, there's nothing in front or in the back of the brackets. No multiplication, nothing to expand, no negative signs, so we can leave this one out. But what about this part here? Here we have a negative being distributed in each part. So we're going to have a negative, negative, which makes this a positive if we take the brackets out. So I'll just make this red to remind you that this is where we edited it. And then the last step here is we need to put them together. 5 is equal to 7x plus, sorry, I didn't actually do it. My bad. 9x plus 6 is equal to 5 to the 3p. And now think about this. If you have a number 5 that has this power, no matter what that power is, it's some number. And the other side also has 5 as the base, and it has some power over here. How can these two be equal? Well, the bases are already the same. The 5s are already the same. So the only way that those two can be the same is if the numerators are the same. Oh my God, I keep saying numerators. I've done too many lessons with fractions in the last couple of days. If the power is going to be the same. So we're going to get 9x plus 6 is equal to 3p. How are you guys doing, nerd? Good to see you again. Oh, right, okay. Where are you from again, nerd, if you're saying good morning? It is 6 p.m. over here. Okay, this question now gives us an equation. Yeah, these are both equal to each other, and it's asking us to find an expression for p in terms of x. So in terms of x means we're looking for a expression, a formula for p, so p equals, and we're allowed to have numbers and x's in it. So if we want to find this for p, well, we need to divide by 3. So we're going to divide 9x by 3, and we're going to divide 6 by 3. And maybe I'll do it in 2 steps. We're going to 9x plus 6, and we're dividing it by 3. And how do we split this up? Leveled up gradually. Yeah, I mean, we started early, right? Because the whole point is to get through all the fundamentals, right? After today, we should have all the basic rules covered. Yeah, and afterwards, the questions are going to get much, much harder, right? Because all of the concepts are juggled together in the actual exam questions, right? Okay, so how do we solve this one here? Again, this was like splitting the fraction. We're going to get 9x over 3 plus 6 over 3. So that was 3x plus 3. So now we have ourselves a formula for p in terms of x. And I'll zoom out a little bit so it all fits on a screen so you guys can have a look at it again. Yeah. So if you guys see any of these questions where there's many different equations in the exponent, I'm not going to say numerator again. Okay, in the exponent, yeah, with multiple x's in there, then this is always the trick that you guys need to do in order to solve it the fastest way. It's always about using log rules and indice rules to simplify these. I can have a look for you guys. I think this question is actually an E question. 1 second. What question was this? Might also just be a merit question. Yeah, it's just a merit question. So finding p is equal to 3x plus 2 is a merit. And it says in order to get to an achieved, you either have to find that 125 is x to 5 to the power of 3, and then use the power rules, right? So if I mark this over here, if you guys get to this step over here, that is an achieved. And I guess writing the question out gives you a merit over here. Okay, wonderful. Now, it's very important that you guys know the difference between when we use this method and when we use this method. Yeah, so that's why I solved kind of 2 questions on the same page here, so you guys see the difference. Here we only have one value in the x in the exponent, one value of or one expression of x, and that's when we use log on both sides because that's the fastest way. Okay. Okay, you guys will have to tell me in the chat. Yeah. So here's a couple of options. Give a read for this question. This is number 1. Yeah. So we have quadratics on both sides, and we have linear equations and fractions on both sides and values of k, and it's asking us to solve for k. Yeah, this is option 1. The second option is this question here, where we have been given a straight line is a tangent to this quadratic with, of course, y's and k's in there. And it's asking to find the value of k and where the quadratic crosses the y-axis. So this is number 2. And let's have a look. Number 3 would be to the last fundamental step, which is finding equations from a graph. Yeah, quadratic equations from a graph. We don't have that much time anymore, so you guys can put in the chat 1, 2, or 3 what you guys want to see. Nice, you learned this in year 11. Yes, I think so. These students here are in year 12. So they would be 16 years old. So this is the New Zealand curriculum. I'm originally from Germany, so I remember a lot of these laws that we also did very, very early on. So I think we did this like in year 10 or 11 as well in Germany. Yeah, which is probably very, very similar to the Dutch curriculum. All right, 1, 2, or 3 in the chat. You guys can decide what we need to do as our last question. Otherwise, I'll make a decision. Okay, giving it another 5 seconds. Oh, we don't really need our calculator. Number 2. Okay, you want to see number 2. I think this is one of the harder questions on, oh, sorry, there we go. This is one of the harder questions on the paper. And let me quickly check. I'm pretty sure this is the excellence question. In New Zealand, we have a system that gives us achieved, which is like the lowest mark. Merit is advanced, and excellence is like the top marks, top 10% of the class. So if I have a look, this question here, it's question 1C, and 1C can give us an achieve. Oh, where is it? 1C. 1C, yeah, it's the excellence question. So it gives us an opportunity to solve for both passing marks and the advanced marks. Where is this question? D. Oh, it's D. Whoops. Yeah, it's still excellence. It's still excellence. Okay. Let's have a look at this question here. So we have 2y is equal to 2x plus 29 is a tangent to the quadratic. First of all, in order to make sense of these questions, we're going to go one by one. We're going to have a look at what this means. This is a tangent to the quadratic. Now, what does it mean to be a tangent? Yeah, a tangent line is a line that just touches our curve at one point. Yeah, so this is our tangent. And that means that at this point here, this straight line has exactly one intersection. Yeah, we have one point where these two intersect. That is what a tangent is. We don't have two intersections and we don't have none. We have exactly one. So have a think of what that means. When do we have one intersection point? Then, of course, the question gives us a quadratic. Now here, the quadratic is in terms of an x and a y altogether. And we have that k is a non-zero constant. Now, usually, and I've said this last time as well, these parts here, they are usually always for the end, where you have to check once you have values for k. So this is definitely the E question. This is the harder question. So maybe we can all work this out together. Now, when we have intersections between two graphs, how do we find intersections between two graphs or two functions? Yeah, we have in year 11 or year 10, we start with simultaneous equations. So we have two straight lines. They are terribly drawn. There we go. And they have exactly one intersection point here. how do we find this intersection point? Basically, if you use simultaneous equations, that means we are substituting one equation into the other. Yeah, or we can make them both in terms of y and then set them equal to each other. We can do both. Yeah. Why can we do this? Because a point of intersection between a tangent line here and the graph itself, if we look at these values x0 and y0, these two x and y values, they share something. Yeah, they are both on the tangent line, on the straight line, at the same time as on the graph. So when we look at the points on the parabola, these x and y points that we have are actually on this line as well. So we need to find a combination of x and y points that work for this at the same time as for this. So with other words, the x and the y values are the same for both. Yeah, the intersection points are the same. So let's take all of this off because we're going to need a little bit of space. Yeah, let's take this off as well. Okay. Now where we have this, where we have our equation, we know it's a tangent line. Let's put this here. We have one x and one y value. That's all we're interested in. So let's have a look. Our equation, the quadratic, is given as x squared minus 2ky plus 32k is equal to 0. So we have an x in there, we have a y in there, and that k, which is just a number. And if we have a look here, 32k, that's just a number as well. And here it's annoying that we have a y. Let's have a look. So you're saying, can we write x squared? Let me write on here so we can all have a look. Plus 32k all over k is equal to 2y. Yeah, so what you've done here, yeah, just for everyone who watches the recording later on when they're prepared for the exam, what you've done here is you move this term over to the other side by doing plus 2ky. And now we divide by k, so we just have the positive y on one side, which is perfectly fine, yes. Now this would not have been my attempt at the question, and I'll tell you exactly why. While this is perfectly fine, hold on, where, yeah, you can also divide by 2, right? Then you get a formula for just y, yeah? I guess you didn't do that because we have a 2y here and you wanted to substitute this in there, right? The reason why I wouldn't have chosen this way is because this here looks much more complicated than this. But in the end, it doesn't matter. Any way works, and if this question is even just one step extra for you, that's perfectly fine. Yeah. So let's keep your approach. Yeah. Let's keep that as our step, and then we solve our question that way. So we're going to do plus 2ky on both sides, and then we're going to get x squared plus 32k is equal to 2ky. And now we're going to divide both sides by k. And this is the part where this part usually comes in very important, because dividing by a k or an x or something is usually very dangerous. Yeah, we always need to be careful because this is where things break in algebra. And that happens if k is equal to 0 or could potentially be 0. But because it's telling us it's a non-zero, so it's not 0, so that means we're okay. So we can do this step. Yeah, so we're going to get x squared plus 32k all over k is equal to 2ky. Oh, sorry, 2y. And now what we have here is we have 2y and we have a 2y here. And we know that those are going to be the same because the y's are the same. So if we now look at the equation at the top, we have 2y is equal to 2x plus 29. And here again, we have 2y. Yeah, so the way that I want you to think about is that this part here is the same as 2y. And this one is the same as 2y. And 2y didn't change, so clearly those two must also be the same. They must be the same. Okay, so what we can do is we can write them together. So we're going to get x squared plus 32k over k is the same as 2x plus 29. And what is the next step here that we need to do? I will simplify this with you, yeah? And then you guys need to keep in mind, why are we doing this and what is our next step here? Maybe I'll simplify to the right so we have more space. I see it's a quadratic. It has a x squared term. So what I want to make sure is I write it in the form ax squared plus bx plus c, because so far everything is all together. There's fractions, there's everything all together bundled up. I don't like a fraction, so I'm actually going to multiply both sides by k again to get rid of the k in the denominator. So let's have a look here. We're going to go over here and we're going to continue our question over here. Yeah, so there we go. So we're going to get x squared plus 32k, 32k is equal to 2x plus 29 all times k. And here we have brackets that we need to expand, right? So we have k times this and k times this. So we have x squared plus 32k is equal to 2kx plus 29k. Hopefully I'm not making a mistake while I'm talking. Very common. So here, what do we have? We have x squared and we have values with an x over here. And then the third part is numbers with no x. And even though it has a k, remember k is just a number. So if we simplify this, we're going to get x squared minus 2kx because we're moving that to the other side. And then we're going to get plus 32k and then minus 29k is equal to 0. Okay, now we need to put these terms together. We're going to get x squared minus 2kx and this is going to be plus 3k equals 0. And I think at this point, you're already getting, one more step in order to get a merit mark. So you've passed already for this question. You've got the minimum requirements to pass, but there's one concept that you guys need to apply here. And we're not going to solve this. Yeah, we're not finding x here. Why not? Because we're not interested in the coordinates where these two intersect. We don't know and we don't care where that point is. But what we do care about that point is that we have exactly one point. Remember here, what we had is we had a quadratic and a linear equation, a straight line and a parabola, and we set them equal to each other. That could result in this situation, it could result in this situation, and it could result in this situation. Oh, sorry. There we go. Yeah, so these are the three situations, and it's telling us that it is this situation over here. We only have one point of intersection. So what was the concept that we talked about today that told us one intersection or one root, or well, one repeated root, the same one twice? That meant that the discriminant is equal to 0. So what we're going to do now is we're going to set the discriminant, and again, you can have a look at the formula sheet it's given to you. It's b squared minus 4ac. We're going to set this equal to 0. And now we're going to substitute in our numbers. Let's have a look. The b is the number in front of the x term. And remember, the number includes a k because k is just a number. So we're going to substitute in this for b. So we're going to get minus 2k all squared minus 4 times. And now I'm substituting in a. And do you see how each time when I substitute in, I put brackets? Because that helps me make sure I apply the square to everything inside the brackets. I never forget. Now, the last part here, c, is the number at the end. So that was our 3k. And that is equal to 0. Okay, let's clean this up and simplify. And then we're going to see where we are. Negative 2 times negative 2 is positive 4, and then k squared, and we're going to get minus 12k is equal to 0. So what does this question here actually tell us? This question tells us that we have an equation for k with no more x. How did we get rid of the x? Because here we're just talking about the discriminant. We're not trying to solve this equation for x anymore, or that was never our plan. We just cared about the discriminant being equal to 0, and that comes from the one sentence that tells us this. Now, how do we solve this? Again, the first thing that we see is we have a squared. So technically we would factorize set equals 0, yeah? And you guys are free to use the calculator here to find the answers. Yeah? So let's put this in. We're going to take out a 4, k squared minus 3k equals 0. After watching our last stream from last week, I expect that you guys know how to factorize these. So I'm just going to do that a little bit faster here. We can, oh, sorry, I should have factored out the k. Yeah, me telling you, you have to know how to do this, but I don't know how to do it myself. Very good. Typical. There we go. We have a k minus 3k, minus 3, oh my god, is equal to 0. There we go. And what does that mean? This means 4k is equal to 0, or we have k minus 3 is 0. And here we get k is 0, or k is 3. Okay, now let's have a look at this massive question that we've done. First, over in the corner, yeah, we started by setting both equations equal to each other. Yeah, now we solved for k by using the discriminant equal to 0. Yeah, very good, well done. Now we get k is 0 and k is 3. Can you guys tell me if k is 0 or k is 3 is a solution? Yeah, are both of them a solution, or just one, or both? What do you guys think? Okay, so you guys had a minute to think. So here in the question before, it told us that k is not 0. So we can ignore the solution that mathematically or algebraically came out. Even though k is 0 is an option here, we told you in the beginning it's not 0. Otherwise, this question wouldn't be the same, right? We wouldn't have all of these terms. So what do we have now? And I'll do it here at the top. We get x squared minus 2 times 3y plus 32 times 3 is 0. So this is now our equation here, right? Okay, so what can we do here? We can simplify, and we get that x squared minus 6y plus, oh, what is that number? 96 is equal to 0. Right? We're almost there. This is an equation x and y. Yeah, so it's only k is equal to 3, and that is because we are not allowing k is 0 by definition. Yeah, algebra tells us, the mathematics part tells us that k is 3 or 0, but because we set certain definitions for that value k, the value k is a mathematical number, any number that we can think of, but we're telling you it's not 0. So even when you do the algebra and the answer comes out as 0, you can completely ignore that and completely just move on from there, because we worked the whole time under the assumption it's not 0. Okay, so what we can do here is we can rearrange this in terms of y. So we're going to get 6y on the other side. Then we're going to get x squared plus 96 is 6y. We can divide both sides by 6, which gives us 1 over 6 x squared plus 32 is equal to y. And now we have an equation for y, which is again a quadratic. And we're still not finished, because the question is telling us find the value of k and determine where the quadratic crosses the y-axis. So we need to find where this one crosses the y-axis. And if you guys remember in the form ax squared plus bx plus c, A here is the scaling that tells us how steep it is. The higher A is, the more steep our parabola is. And if it's negative, it would be upside down. B doesn't really tell us anything, really. It's not very reliable for us to understand what it looks like, but it kind of moves the parabola in another parabola shape back and forth. So it's kind of unreliable. But we should know that the C here is the y-intercept, the part where our graph crosses the y-axis. So since we are in this form here, this is our C. So we have now found 32, which is the final answer. So we have the answer here as 32 is the y-intercept. And getting to this part here will give you the highest mark for the paper, which is the top 10%, the excellence. I mean, yeah, absolutely. Yeah, I mean, even though I live in New Zealand at the moment and I'm teaching in New Zealand, mathematics isn't really different in all the different countries, right? It's basically the same. The one thing that we kind of have differences is how we write things. Like for example, in Europe, I would, for example, write this as a 1. Here we would have this as a 7, right? And here we write 1 times 2. And in Germany, I would kind of write 1 times 2 with a dot, right? But besides how we write things down, the ideas, the logic, the mathematical rules, everything is the same, right? Yeah, so I quite like these kind of questions, and I'm glad it helped you. Some of these harder questions I think are really, really good practice because they need a lot of concept knowledge. We need to really understand what it means. What does the discriminant do? The part in the quadratic formula, what is that for? How do we solve and manipulate quadratic equations? Yeah, it's not x on one side, it's everything to one side equals 0, then factorize. Yeah, so there's a lot of concepts, and of course it's all the same in all the different countries. Yeah, so I'm glad it helped you as well. Awesome. Hopefully you did give me a like. Yeah, you've been here throughout the whole lesson, and this is probably the end for our live stream for today. I've done about an hour and a half, a bit longer than I wanted to do for today, but that's all right. Feel free for all the people watching on the YouTube later on. Feel free to give these questions a go. Yeah, these questions are also quite long, but with everything that we've done in our 2 streams, you should be able to solve all those questions, even though it might be a whole page of working. Yeah, so we have seen here quadratics, so we can factorize. How do we get rid of a fraction? Multiplying by the bottom, maybe something cancels out. Then solving, if you move things around. If you're left with another quadratic, then how do you solve it? Equals 0, factorize again. Yeah. If you're not sure how to do these, go through what I've just said part by part and see if that helps. Computer science, nice. Yeah, no, very good. Computer science is very good. I did a couple of papers in computer science at uni as well when I did my math and stats degree. And they were fun. Yeah, I've especially done the logic papers. I can't remember what it was called, but it was mainly logic, mathematical logic, sense making, and solving strategies that I did. A little bit of coding, but that's not really too much with mathematics, right? But yeah, definitely fun. There's quite a lot of math involved in computer science, so you'll probably be doing quite a few of these mathematical questions in some of those courses in the computer science degree, right? Yeah. Okay. Wonderful. Well, with that, everyone, this is the end of our 2 streams. Now we have done all the fundamentals so far for algebra. Now what we're going to do next week for level 2 is that we are going to do the second topic, which is going to be, I think it is calculus. Yeah, so next week we have calculus, which is the basic fundamental understanding of calculus. I've done a differentiation stream already on Monday, but if you are in New Zealand for level 2, you don't need to watch that one. That will be very confusing. That is 1 year ahead of you guys. Yeah, so these are all the algebra questions. If you guys want to see more questions, put it in the comments down below. I can always add them in the comments later. I read all the comments. I eat them all. Yeah, absolutely. Yeah, other than that, thank you